What's up, boys and girls? It's your proverbial boy Rock again in this video, in this second part of solving this daily kata. It is the first time I had to segment it because I ran into a wall. Now I got out the trash, I drank some water, and I said, without looking further, without looking at videos and stuff like that, how can we make this work? And I thought of a solution which might not be the optimal one, but it could at least do the job and finish it. So we will again from url lib.parse import the URL parse method. Then we shall delete this pattern and we shall make the we shall comment this out and we shall just delete this since it's not that important, and we shall just say, let's just say A or domain, or even better, the netlock or network location part. Network location part is URL parse, and this is URL parse URL dot netlock. Alright, and then we shall print out the network location part. Alright, and we got google.com and google da. And we shall then just make a pattern like only words and anything goes. Then we shall test it out. Oh, and then we shall apply this thing. Then we shall say domain name we shall apply in this pattern to the network location part. We shall find it. Alright. Oh, and we shall print out the domain name. Test it out. As we can see, there is no solution in the second. That is because it is not a URL. I forgot it from before. It does not count this one. Alright. Well, I thought wrong on my visit to the garbage can. We cannot solve it like this. So let us just skip that. Alright. Cancel that. Let's just help ourselves with a Corey safer Python RegEx video. How to write and match regular expressions.
Hey there, how's it going, everybody? In this video, we're going to learn how to work with regular expressions in Python using the built-in RE module. And sometimes you'll hear these called RegEx because there's just so much that we can do with them. So,
all right, now, as you can see, this is like a 50 minutes video. Ah, alright,
We
nice.
should now have a pretty good understanding of working with regular expressions in Python, but we've been using this find iter method throughout the whole video, and that's because
Yeah, he's writing this stuff, you know. So, I don't know about this guy who says, if you're coming from the previous RegEx video, start from here to skip all the things already explained. But if we accept this dude's proposition, we don't understand these R strings, you know. So, thanks, no sweat. Glad. Actually watch the first 7 minutes on start and skip to alright. I'll do whatever this guy said, you know. Let's watch the first 7 minutes.
Hey there, how's it going, everybody? In this video, we're going to learn how to work with regular expressions in Python using the built-in RE module. And sometimes
I hope the YouTube, when I upload this video, won't cancel me, you know, because I'm watching another YouTube video.
you'll hear these called RegExes. Now, I recently released a video on regular expressions as a standalone topic because they can actually be used independently of any one programming language. So you can use them.
But in the end, I'm just like making kind of a commercial for this guy, so I think it's not like ethically wrong for me to include this video in my video.
Search for text patterns within text editors and things like that. So this video will use a lot of those same examples that I used in that video, except here we're going to see a lot more that is Python specific. So if you've never used regular expressions, they basically allow us to search for and match specific patterns of text. And they can look extremely complicated, but that's mainly because there's just so much that we can do with them. So you can create a regular expression for just about any pattern of text that you can think of. So let's look at some examples and see what this looks like. So I have a Python module here that we're going to use to search for some simple patterns to start out. So first of all, to use regular expressions within Python, we need to import the RE module, which obviously stands for regular expressions. So I'm doing that up here on line 1, and the text that we're going to be searching is this
or you know, or just, I have a better idea. What if we just say Python regex get domain name from URL? Yeah, extract domain name from URL. I'm trying to extract the domain names out of URLs, just like in here. My problem is that my URLs can be about everything. Like this, like that, and so on. The diversity of the domains doesn't allow me to use regex as shown over here. Now let's see. All right. Use TLD extract. Extract results subdomain. Forums.news. Domain suffix. Accurately separates the GTLD or CCTLD from the registered domain and subdomains. Alright, this answer is really interesting. Why do we just use this TLD extract? Like right now I'm really tired, I just want to wrap this up. Even if that means, to confess, alright, I don't fully understand these regular expressions right now and I'm used to really URL parse. Yeah, thank you Peter Wood, I already tried it. Alright, let's try this. TLDE extract. Extract. Then we just say extraction. How we use this? Dot extract. Just call TLDE extract dot extract. Let's say URL, and then we then we just comment this out, say print, or no, we'll use this print statement. Extraction test. No model TLD extract. Alright. Tilde. Did I write it wrong? No? Alright, there is no such model apparently, or at least in this one. So we can't use that. Alright. Alright. Let's just watch the tutorial.
Multi-line string here. So the variable name is text to search, and we have a lot of things in here in this multi-line string. So you can see at the top we have some lowercase, some uppercase, some digits, just some special characters, a URL, phone numbers, and some names. And also have a simple sentence here that we're going to use in an example as well. Now before writing our first regular expression, we need to know what a raw string is, because we're going to be using these a lot throughout this video. Now a raw string in Python is just a string prefixed with an R, and that tells Python not to handle backslash.
Oh, that's an R string, it's a raw string.
In any special way. So for example, normally backslashes are used to specify tabs or new lines and things like that. So if I was to print out the string \t and then just the text tab, so if I run this, then we can see that Python replaced our \t with an actual tab. But a raw string will just interpret the string literally. So if we put an R in front of this string and then run this, then we can see that the backslash is no longer handled in any special way. And that's important because we want our regular expressions to interpret the strings we're passing in and not have Python doing anything to them first. So we'll be using these raw strings throughout the video, so just be aware of what these are. Okay, so let's write some expressions and search for some patterns. So to write our patterns, I'm going to use the re.compile method. The compile method will allow us to separate out our patterns into a variable, and also will make it easier to reuse that variable to perform multiple searches.
Alright, so that's what we want. We wanna...
So to use this, we can just say that our pattern is equal to re.compile, and now we can specify our pattern. So first let's just create a pattern that matches some literal characters. So if we just wanted to search for the literal text ABC, then we could say R for our raw string, and then we could just pass in the literal text ABC. And now that we have that pattern specified, now let's actually search through our text with that pattern. So I'm going to create a variable here called matches, and I'm going to set this equal to that pattern dot find iter, and I'll explain this more in just a second. But what we want to search is our very long string up here at the top, our multi-line string called text to search. So I'm going to paste that in. And now to print out all of our matches, I'm just going to do a for loop, and I'm going to say for match in matches. Print out the match.
Alright, alright. This is a little too fast for me. I'm really slow, dude.
Paste that up here at the top, our multi-line string called text to search. So I'm going to paste that in. And now to print out all of our matches, I'm just going to do a for loop, and I'm going to say for match in matches, print out the match. So if we save that and run it, then we can see that this find iter method returns an iterator that contains all of the matches. So we're going to look at more regular expression methods later in the video, but I think that find iter is one of the best for gathering all of the matches in an easy to read format. So each of these match objects shows us the span and the match itself. So the span is the beginning and end index of the match. So when we search this text with this pattern using the find iter method, it only found one match of ABC, and it found it in our alphabet from indexes 1 to 4. Now these indexes are useful because it allows us to use the string slicing functionality in Python, where we could just plug in these values and get the exact match. So if I was to print out our string from indexes 1 to 4, so I will print out text to search from indexes 1 to 4. Now if I run that, then we can see that we got ABC, and that is the exact value that we matched. Now,
alright, fair. That looks dope.
Now, if you've never seen this string slicing functionality before and would like to see more of what you can do with that, then I do have a separate video on that specific topic, and I'll put a link to that in the description section below. But for now, I'll just go ahead and remove that. Now, if I make my screen a little larger here, and if we look at our text to search, then this is the literal ABC that it matched right here. But notice it didn't match this capital ABC, and that's because this is case sensitive. And this search right now is also looking specifically for ABC in that order. So if we were to instead come down here and search for CBA and run that, then you can see that we don't get any matches. Now, if we scroll up here and look at this meta character section, then I have some examples of characters that I say need to be escaped. So say, for example, that I wanted to search for a literal period. Now, if I just put a period in my search, so if I change my pattern to where it is only searching for a period, and I run this, then we can see where it does this weird thing where it matches
finds just everything.
And that's because the dot is a special character in regular expressions, and we'll see what that is in just a second. But if we just want to actually search for a period, then we have to escape it. And we can escape these characters with a backslash. So within my pattern here, I'm going to put a backslash before the period. And if I run that, then we can see that if we look at all of our matches here, then all of these matches are actual literal periods from our text. So escaping those characters goes for any of these characters here in the meta characters section that I say needs to be escaped. Now, one practical example of this might be a URL. So I have a URL here that is coreyms.com. Now, if we wanted to match this exact URL, then we would need to escape the dot in that URL by saying something like, so I'll change my search pattern here, and I'll just search for a literal Corey MS. And then for the dot, I would need to escape that dot, so /.com. So if I save that and run it, then we can see that we did match that URL. Okay, so a literal search isn't too exciting because that's something that we probably already know how to do within Python.
Yeah.
Really, we want to use regular expressions to search for patterns. And to do this, we're going to use some of those meta characters that we were just escaping. So in my snippets file here, I have a list of values where we
Alright,
can see
now
the
he
types of
explains
characters,
everything
a
that we
common
already
theme
know.
with the, now we can't just type matched cat, mat, pat pile. And now we
It's
want to put
basically
a
the same as in
regular
previous
expression pattern
video.
within here. So first let's just
And
match
then we go
everything
to the
before the @ symbol,
4.3.
the entire URL. So this would be group 0 here. So to and then our top level domain, we want to include the dot, so this would be the .com or the .gov. So we'll put the parentheses before the dot, and then here at the very end. So since we just added groups to an existing expression, that shouldn't actually change our results. So if we rerun this, we can see that we still get the same results there. But now we actually have 3 different groups. So the first group is the optional www. The second group are the word characters that make up the domain name. And the third group is the top level domain, which is the .com or the .gov. Now there's also a group 0, and group 0 is everything that we captured. So in this case, it's just the entire URL. So this would be group 0 here. So to show this, our match object down here that we are iterating through, this match object actually has a group method, and we can pass in the index of the group that we want to see. So we can say .group to use that group method.
Alright.
Now we can print out group 0 by just doing group.
Alright, now this means we basically got it. You know, we basically got it. Because we just say pattern is, first we say RE, then we say pattern is re.compile, and we write our pattern over here. 9. Oh my god. Let's put it over here. Alright. Then we put this over here. And it's a raw string, you know, we want to work with the raw string. Then we just say match, because here it will only be one match, you know, like right here. And then we say pattern find iter URLs, no, just URL, and then print match. Alright, and in the group we say first we've got an HTTP and / or HTTPS / or www dot, and that can be 1 or 0. And then we have letters A to Z, also uppercase letters A to Z, and we have a dash, and that can be not 1 or more. It's plus, it's 1 or more. And then there's a dot. Alright, let's test it out. Iterator object, callable iterator object. Alright, now that's an object, so let's do it again. For, let's just say matches. Let's do it the same as I did in tutorial. We just say for match in matches. Say print match, and we see if maybe this is any different. No, it's not different. Alright, so let's explore this. It's already 20 minutes past midnight. Oh no, daily kata. Yeah, it doesn't matter. Print match, and then let's just say dir, so we say what kind of things we can call upon this variable. Say class, delete attribute. Alright, this isn't really helpful, I guess. Format new. Alright, find iter URL, compile R. Okay.
Zero. So if we print that out, then like I said, group 0.
Alright, let's rewind. Let's do it again as the dudes did, and we say group zero, and I prefer to get like a I prefer to work from here. No, but it just 0, like 4 matches. It just doesn't run. I'm like, what? Why is there no? Well, at least throw me an error, you know. No loop. Let's just see if it even enters the loop. It doesn't even enter the loop. Matches, because apparently there are no matches. Alright, what if we delete this? Test it out. Loop. There's plenty of loops. What if we print matches? Callable iterator object. Alright. And in this instance, if we Like I don't know why it looped so many times. I don't understand. Maybe for every, like maybe it put every thing, you know. So we say here we got another group which is like everything but not a dot, or something that finishes with a dot. Or like no, we say A to Z, and it's usually lowercase and dash. And maybe it's a question mark. No? We say plus. No? Do we put this thing over here? I'm kinda confused. Like what's the second step? It's like, alright, it's this, and then it's like words, like W, everything. Huh? It's like multiple HTTP, Google, then com, and then JP. Alright, and then we just print group 1 test. None. Then we print out group 0. Alright. Alright, the cat is meowing, I don't know why. Oh, I really don't know. I really don't know. Huh. Let's do it exactly as it's over here. So we say this and then escape the dot and then everything. Let's test it out. Alright. Google COJ. Alright. I don't know why the cat is meowing. Is there something wrong? I don't know. Now why doesn't that work? 'Cause then we can just call a group first, because if this is the first group, we want to know the second group. For matching matches. Yeah, because this is the thing. I'm working with stuff that I don't fully understand.
Is the entire match, so that's just the entire URL. Now, if we printed group 1, this should be the optional www. So if we save that and run it, then we can see that the URLs that have a www dot print that out as the group, and the ones that don't just print out none values. So our group 2 here should be our domain name. So if I print out group 2 and run that, then we can see that that's what we got. So we got Google, QueryMS, YouTube, and NASA. Now group 3 should be our top level domains. So if we print out group 3 and run that, then you can see that we get .com, 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 and .gov. Now we can use something called a back reference to reference our captured group, and it's basically just a shorthand for accessing these group indexes. So the regular expression module has a sub method that we can use to perform a substitution. So let's see what this looks like, and we can substitute in these back references which reference the groups. So for example, let's just show an example and that will become more clear. So I can create a subbed URLs variable here, and I will set that equal to pattern.sub, and now we want to pass in the substitution. So the substitution that we want to use are these back references that reference these groups. So we wanted to replace these URLs with the domain name and the top level domain. So the domain name was group 2, and we use these back references with a backslash and then the number of the group. So we want to replace these with a /2, which is the domain name, and then a /3, which is the top level domain. And now we need to pass in the text that we want to replace. So let me walk through this one more time just because that can be a little confusing. So here we are creating a pattern, and this pattern, as we saw, matches all
2 and 3 and URLs. Okay. Pattern. So let's use this pattern.sub. So we say like solution should be pattern dot pattern dot sub, and then we say raw string, and then we call upon the second, I guess. Yes, second. Oh, these groups do not count from. These groups do not count from 0, they count from 1. Alright, from 2, alright. And then if we delete everything over here, and just say print solution, alright, google.com. Okay, Google okay. We must press a plus over here. Google.com, google.jp. I don't want this JP in the end. Back to the Corey Schaeffer's video, learning regular expressions. Oh, I know. Instead of W, you just use a normal dot here, which means for all characters. Google, alright. And we just return solution, you know. I think we did it. I think the spy did not understand. Oh, no, we didn't. Should equal -site. Alright. www should equal this thing. So I guess we need to get into account that there can be www dot after the HTTP or HTTPS. Okay. Why not? Kata should equal Google. Because this is the second group now. Alright. So now we look at the third group. Oh my god, it should be as clear as day. and this should be all green. One is still red. HTTPS hyphen site should equal. Alright, now let's just print out the URL and see. Alright, I have to check out on the cat. Alright, so we print it out and let's see what is going on over here. Okay. So, like, here is the thing is that we've got a hyphen, you know, hyphen over here. Alright, so we just saw, I guess that is this niche thing that we have to figure out for ourselves, and that is how to include in this group that there can be words and also hyphens. So we say maybe just make a
Hey there, how's it going, everybody?
Google search for RegEx, and we say check for letters and hyphens in a group. Allow letters, numbers, underscores and hyphens. You say the means more than one character. No one B. Now. Oh, I know. It's like any number of words and then it's a hyphen. No, it's any number of words or any number of words and hyphen. And also any number of words, but this is a case specific example, but it still doesn't work. Oh, because we forgot the plus over here, if I understand it correctly. Yeah, but so we solved this thing but this is very case specific thing, you know. This is a very case specific thing. So let's, like, now that we know that it works, we can do it. So let's just take an extra mile and say there can be like words and hyphens. Press attempt. Alright, it doesn't work. Alright, I guess that kinda. Alright, so we say there can be words or words. Oops. Like, what's up, cat? I think it's getting into puberty and it wants to mate. That's the only explanation. It has water, it has food, it has toys. So let's just submit that. Alright, submitting. And of course, oh my god, I cannot believe it. This is the best practice, and also, oh no, this is the cleverest, but also the best practice. I don't know if it's the cleverest, but it just like splits at. Now the good thing about split command is that it works no matter if this thing is there or not. So this or this or this, and I don't fully understand this one. So first you split it at this mark and then you go one back, like so. You leave the HTTP part and then split it out at www dot, and then you leave it at that, and then split it at dot and you leave it at, alright, I understand it. This is really smart. Like, props to all these guys and girls. So yeah, here's our solution. We used RegEx and this funny little niche thing that we really thought for ourselves. And I'm tired. I'm kind of exhausted. I don't feel as accomplished because I thought, oh, now I will really understand regular expressions and solve this equation. But I really don't. I kinda do. But I guess that's just the nature of programming. I guess you need to really be at peace when it's done. So it is done. Thank you for watching. Thank you for bearing with me, and have a nice day.